from Texas. If there's anybody who is having trouble hearing or seeing the presentation, please let us know. So you can either message or text Medi or let us know on the phone. So, okay, if not, then maybe we'll get started. I have here with me Mehdi Hosseini, who most of you know through, at least through Laura, and new addition to our team, Nina Jiao, who will be helping as well. So what we'll do this morning, I'm going to start with just a brief introduction to the project. I've had you know, at IGARS, I've had a few questions about some of the questions about the project, so I'd like to go over those before I hand it over to Mehdi and Laura to go through more of the technical presentation. So please feel free to ask questions as we go, or we'll have plenty of time after the presentation to answer your questions. All right, Mehdi, with that, let's go on to the next slide. So I just wanted to go over a little bit about what some of the overall objectives of the project are. So what we're being funded to do is advance the use of radar or a combination of radar and optical data for mapping and monitoring crops across diverse cropping systems. So, you know, I underlined the words SAR because just to make it, you know, absolutely clear that, you know, anything that we're doing in this particular project, there has to be a radar component to the mapping and the modeling. As well, this is both a research and a tech transfer activity. So the research will happen throughout the entire 3 years of the project, and there will be sort of this training aspect. And it came up in a recent conversation we had with one of the partners that we may not want to wait till years to do the training. So we're thinking a little bit about how to earlier than at the end of the project, and I'll talk about that in a minute. So, and again, although this is a research-focused project, we most certainly want to make sure, as much as we can, that those institutions who are mandated to do sort of the operational mapping and monitoring, that they are either in the project or that they are connected with the partners that are in the project. So next slide, Mehdi. So just to remind you, there are two principal investigators on the project, so Andy Davidson and myself. But the real leads on sort of the daily aspects of the project are Laura is leading the crop classification aspect, and Mehdi is leading the LAI Biomass. We received 3 years of funding from the Canadian Space Agency, so the funding began in April 2017, and that's why, although there were data acquisitions occurring before that, you didn't see too much activity happening until April. That's because that's when the funding started and when we were able to hire Mehdi. So the good news is that they are working full-time on the project, so we expect a significant progress in this area of research. And our outcomes, you know, I think most important from my perspective is that the methods that we develop, they need to be robust, and that means not only do they need to be accurate, but they need to be repeatable across time and space, you know, regardless of what methodology we're talking about. So we're trying to develop a methodology for the crop type classification, and which Laura is leading, and then a second methodology to look at indicators of productivity. So here we're focused on LAI and above ground biomass. It's possible that there could be one universal method that works across diverse cropping systems. It's not likely that we will come out at the end of this project with a single methodology. It's likely that it'll either be one methodology with certain adaptations or variations, or there could be, more than one project or more than one methodology. And Mehdi made a good point yesterday when we were doing the project that he's developed a toolbox basically that will ingest radar data and produce biomass or LAI maps from radar set 2 data, and we could code into that toolbox additional models as well, so that the users could choose the model that they want to apply. So we could have one sort of toolbox that would contain more than one modeling approach. And again, there'll be some training and transfer of the knowledge and tools. This was asked by some of the partners as well, and it is our full intent to make sure that the methodologies and any tools that we develop, that they are available to the partners throughout and most certainly at the end of the project. So that will be a two-way exchange for sure. So those will be made available to anybody who's participating.
Heather, I have a question. Considering the toolbox.
Yes?
Yeah, it's Sergey Skakun from UMD. Is it will be only for RadarSat-2, or are there any plans for Sentinel?
No, we're absolutely planning to use Sentinel data. Our toolbox has been focused on RadarSat-2 because we just haven't had a chance to work with the Sentinel data yet. But yeah, the models that Mehdi is developing would be completely adaptable to Sentinel-2. So the toolbox,
great.
The toolbox also has the models right now to derive LAI from optical data. So we could have a toolbox where you can get LAI and biomass from optical data, Sentinel-2, RadarSat-2, or a combination of those. So, yeah.
Thank you.
Okay, next slide, Mehdi. So a little bit of the responsibility. So from the Canadian team, obviously we're trying to trying to coordinate some of the new data collection. We will gather, collate, quality check, and validate all of the in situ measures to make sure that we have a high quality data set that will be available to all the participants. So that's our job that's why Laura is asking you to send your data so that we can go through it and put it in a format that will be available to everybody. Laura is also leading the pre-processing of the satellite data that will be made available to all the participants as well. That doesn't preclude you from applying your own pre-processes if you like, but we will be using a standard pre-processed data set. Our intent from the Canadian team's perspective is we will be focused on testing, our methods that we've developed, which is a decision tree approach to classification and the water cloud model for the LAI biomass across all of these international sites, and to develop some new models for perhaps some selected crops that we haven't modeled yet, and then to statistically compare our methods and the methods that the partners or the results from the partners approaches to crop classification, so we can have sort of this standard understanding of this intercomparison of methodologies. And then, of course, to transfer the knowledge to and methods to the partners. So that's our responsibility. And I guess I wanted to raise this issue because I don't want to leave the impression that, we are solely and only focused on our own methodologies, but our resources will be dedicated to that. So having said that, for the partners in the project, your responsibilities are to provide in situ data so that Agriculture Canada and others can apply methodologies to the data. And as an option, there will be some JECAM partners who perhaps don't have their own methodologies, and so they will just be providing the in-situ data, and we will be applying the Canadian methods to them. But there will be other JECAM partners, and we know this, that have their own methodologies that they would like to try on the Canadian sites and the other JECAM sites. So that is open to all the partners to do so. So if you have a classification approach or a modeling approach that you want to try, then the data, the in-situ and satellite data will be made available to you to try your own methodologies. But I just wanted to make it clear we're not going to do that. We will be testing our own methods, but all of the data will be available to others to test their models. But we do want to have, at the end of the day, we do want to have an understanding of this intercomparison. So hence why we're trying to sort of standardize the processing of the in-situ data and the pre-processing of the satellite data. You know, otherwise we come out with a bunch of different methods that are not intercomparable. And you know, for your requirements, that might be fine. But I think for the the funding that we're getting from the space agency, we want to see a true intercomparison.
I have a question, Heather. Concerning the comparison, is there part of the data set that will be test-based and the other one for validation, or do you make everything available, or do you keep some for blind testing? Did you think about this?
Well, we always do that. So on the classification or on the modeling, like we always hold back some of the data for validation that aren't included in the training of the classifier or the modeling. So we will do that. We do that as a standard practice. But I mean, that's a good point for for all the participants. If you're applying your own methodology, we have to have a true validation independent data set to do that.
I will explain it on my presentation more about that.
Okay, next slide. So some of the next steps, so Laura is busy coordinating uploading of all of your in-situ data. They are having meetings with individual partners on a more or less weekly basis. And so they may be contacting you to set up a meeting just so that they can understand and ask questions about some of your in-situ data. The data pre-processing from the satellite data has already begun, so we have a student here and she's plowing through the pre-processing of the satellite data. As soon as all of the in-situ and satellite data are pre-processed and ready, Laura will notify you that the data sets are ready. And like I said, if you're not planning on doing any analysis, it's fine. You don't need to do anything. We will take care of applying the methods. But if you do have your own methodology you want to try, then that would be the time that Laura will make sure that you can access all of that data. So depending on how quickly the in-situ data comes in, it's coming in slowly. So depending on how quickly we can get that data in, we certainly expect to have results in the next 6 to 12 months in terms of classification. And Laura even told me yesterday that they're ready to start classifying some of the sites already because they have the data set available. So we will see some results coming in very quickly. As some of you know, especially if you were at IGARS, NASA is developing some data cubes. This is sort of a new strategy they have to develop these data layers of pre-processed satellite data over sites, and JECAM is one. The JECAM sites are some that they're talking about. And I spoke with them about sort of building on top of those data cubes these methodologies as well, so that countries would have access not only to pre-processed satellite data, but also the tools. For example, the Biomass LAI retrieval tool that we're developing here, that would also be built on top of the data cube. And I also, when I was at IGARS, I also talked with the chair of the 2018 IGARS and proposed that we have a special event next IGARS specifically for JECAM. Not a special session, but probably a special event, which would give us lots of flexibility. We could have panel discussions, we could have presentations, and spend more time discussing in meetings. So that I'm going to be putting forward a proposal like that for IGARs. Next, Mehdi. Some of the comments that we had from the partners. So there have been some questions about policy around sharing of the data and publication, and Laura did send out a draft policy to everybody on those things, and I think we only have one comment back so far. So please read those and provide comments if you have any to provide. This is our initial thinking around this activity, and that is that if you're providing in situ data into the project and you are expecting to access everybody else's in situ data, then I think it's fair to expect that, you know, your data set would be available to the entire JECAM family. So if I'm providing data in and then I'm using data from, you know, from all of the partners, then my data would be also available to all the partners. So it would be a global data set available just within the JECAM family. If there is an issue around that, we can deal with that on a one-by-one basis. So if you're more comfortable with more of a bilateral exchange, that is possible as well. But obviously, you know, you can't expect to access the entire data set if you aren't willing to provide your data to everybody. But there can be special circumstances where perhaps more of a bilateral exchange is better fit for you. And then after 2020, after the project ends, we can consider providing the data globally available. We did this with the SMAPVEX campaign in 2012, and the same will be in the 2016 data, and it has generated just an incredible amount of research. So it's, you know, I think that that's a very positive thing. But this is a dialogue, so please, if you have other ideas, maybe you have a better idea or variations of that, please do let us know. But we do want to have a data policy and some understanding from the partners. And also concerns around publication as well. So, and again, I think it's fair to say that if you're using another partner's data in a meaningful way in your analysis, that there would be a consideration of authorship for that partner. So. So do take a look at those data policies. And so are there any questions before we get into the technical part of the presentation?
Yes, I have a question. My name is Thorsten Dams, University of Würzburg. If I would like to use the in situ data for my PhD thesis, how should I, let's say, make it visible that the data is not only from me, but from the entire network? Or should?
Yeah, that's a good question. So I'll tell you how NASA approached it with the SMAP campaign, and I'll tell you the advantages and disadvantages. So they said the initial data policy around SMAP in terms of the international soil moisture networks that were being used is that, you know, if the data from those networks were being used, that there was a co-author, that the leads of those that particular network was added as a co-author. So that was the policy that NASA put forward. Regardless of whether it was being used for what the purpose of you know, whether it was a thesis or just a publication. So that was the approach that the SMAP team took. The disadvantage for that is that we get these papers with an enormous number of co-authors on it. So that's a little bit of, and that's what we've been struggling a little bit about the policy. So if we insist, so for example, if you're using data from Argentina, if we insist that the Argentinian lead be on the authorship, and you're using data from 25 sites, well, now you have 25 co-authors on it. So, you know, I'd welcome any comments if anybody has anything that they want to say. That's why I sort of underline this issue about using it in a meaningful way. You know, so if it's, and I guess that's a pretty qualitative way of saying things, but anyway, I would encourage, if others are uncomfortable with that approach that I just suggested, where if you're using the data that there's a co-authorship offered for the lead for that, then please let me know.
Mm-hmm. Thanks.
You can see I'm struggling a little bit with it, and that's why we sent this document out and asking for comments, because it's a bit of a balance, because there is a lot of effort that goes into collecting this in situ data, and you know, we do want the people that are leading that to have some recognition of that, but there's a balance between that and having 25 authors, especially if you're a PhD student. So if partners are uncomfortable with that, you know, please let me know.
I have one question, Heather. Is it, Katarzyna speaking, is it, do you have Sentinel-1 data for your sites in Canada? It's one thing. The partners who are sharing the data, how many partners they have there who have only Sentinel-1 data and Sentinel-2 data, as we have. We don't have RadarSat data. This is the question that has to be arised about availability of RadarSat data for next year for JECAM sites, that we can start to have it over there and then make a comparison with Sentinel-1 and results and Sentinel-2. So that will be very good. But at the moment, we are covered by Sentinel-1 and Sentinel-2.
Okay, so Laura was nodding that, yes, we have Sentinel-1 data over the Canadian sites. So that I think answers your first question. So Laura is going through right now all of the sites, and we're trying to get an understanding of what satellite data is available all over the different sites. So not all of the sites have RadarSat-2 data over them. And we have been approached by some partners, including yourself, about new programming of RadarSat-2 data over these sites. So this is kind of an open question at the moment, and we're going to meet hopefully next week here at Agriculture Canada to discuss that. So we're hopefully going to have an answer to the partners about new data collections for RadarSat-2. Of course, Sentinel-1 is not an issue, and I think Laura is going through all of the different sites, and any of the sort of freely available data, Landsat, Sentinel-1, Sentinel-2, all of that data over all the sites is being scoped out and being downloaded. And the open question is for the sites where RadarSat-2 has not been collected yet, whether we can go back to the Space Agency and ask for new data collection. So we are going to get back to all the partners about that. So anyway, before I hand it over to Mehdi, so, you know, in terms of the data policy and authorship, please do provide us with your comments, because as you can see, I am struggling myself a little bit about what the fairest approach is. So do please provide those comments back. And don't be shy to tell us that you disagree with us if that's the case. So I'm going to hand it over to Mehdi now, and he will walk you through the technical part.
Hello, everyone. My name is Mehdi Hosseini. Thanks, Heather, for explaining the project objectives and all the logistics. So here I'm going to talk more about the technical part of this project. I will explain the data requirements, and after that I will talk a little bit about the process that we are using for LAI and biomass estimation. Then I will show you some results, and at the end, Laura is giving you some updates on the project. So for the second component of the JECAM SAR intercomparison project, actually we are focused on the LAI and biomass estimation by LAI and biomass modeling. These two are the two important indicators for crop yield monitoring. So we are actually going to model two different types of LAI, true LAI and effective LAI. True LAI is 1/2 of the total green leaf area in 1 square meter, and effective LAI is 1/2 of the total area of light intercepted by leaves in 1 square meter. So the difference is that actually the range of these two different types of LAI are different. So usually true LAI has wider range than effective LAI. For instance, for corn crop type, we have LAI of 0 to 8 for true LAI and approximately 0 to 4 for effective LAI. So actually during the last decade, we use a lot optical satellite data for LAI monitoring, and it was actually successful. But the main limitation was the cloud cover, and actually during the growing season that we need dense vegetation, dense observation, we usually don't have enough data to be able to monitor the crop growth during this growing season. So the main advantage of SAR is that we don't have any concern about the cloud cover anymore by using SAR data. And also, SAR scattering is very strongly directed to the LAI and biomass. So these two are actually both are two advantages of using SAR for crop monitoring. So what is the process actually that we are using for LAI and biomass estimation? First of all, we need to calibrate the model. So we are calibrating the model for each crop type and estimating specific coefficients for each type of crop. When we have the coefficients, by using these coefficients and the toolbox that we develop here in Agriculture Canada, we could very easily produce LAI map or biomass map. It just needs the radar data and these coefficients. But for estimating these coefficients, we need SAR and ground data. So the SAR data could be multipolarization or multi-frequency. For multipolarization, we need at least two polarization. One should be HV, and the other one could be HH or VV. So we need at least two polarization, HV or VVHV. Or it could be multi-frequency, at least again two frequencies between X, P, and L band. For ground data, what we need is soil moisture and LAI, or soil moisture and biomass, depends on our objective. So we at least need soil moisture and LAI plus multi-polarization, at least two polarization SAR data for calibrating the model for LAI, and soil moisture and biomass and multi-polarization SAR data for calibrating it for biomass. So the data that is required for the modeling part is LAI, which are true LAI and effective LAI. Biomass, which is actually the total above ground dry biomass. I mean, if dry biomass is not available, we can use wet biomass and calibrate the model for wet biomass, but we prefer using dry biomass. For wheat crop type, we also calibrating the model for heads of the wheat, because it's very strongly correlated with the SAR scattering, so we can say accurately calibrate the model for the heads of wheat as well. We need soil moisture as well. The soil moisture should be the calibrated volumetric soil moisture for the top 6 centimeter soil surface. We are also using phenology information, so we can produce just one set of coefficients for the whole growing season, or we can produce different set of coefficients for different stages of crop growth. So if we have the phenology information, we can produce different set of coefficients during the growing season, and if we don't have that, we just produce one set of coefficients. For sure, by using phenology information, the final LAI and crop map would be more accurate. So the model accuracy strongly depends on the data that we are using. I mean, especially the ground data. So to be able to use this model for the whole growing season, we would need to use LAI and biomass and soil moisture for the whole growing season. I mean, the LAI needs to cover the whole range of LAI value to be able to use it in any time during the growing season. So it's important to have the LAI and biomass value from early season to the end of season. In terms of crop type, we are focused on 4 globally important crop types, which are corn, soybean, wheat, and rice. Still, there is a room to discuss about other crop types as well, if any other crop type is interested to any other JECAM partner. But we are focused on these 4 crop types. In terms of the data, the number of fields and sites that is needed for the calibration part, actually it depends to the number of sites in each field. And also it depends to how frequently we are measuring, we are doing our ground measurements. So I can roughly say that for calibration at each chronology state, for each crop type, we at least need 20 to 30 points. So it depends on how many sites, how many points we have in each field, and how many times we are doing our measurements. So we can say how many fields we need for each crop type. And in terms of the size of the field, it depends on the spatial resolution of satellites. For instance, for RadarSat-2 in standard mode, the resolution is around 10 meters. We are usually using a 5x5 filter to extract the backscatter coefficients. So 5x5 for RadarSat-2 standard mode means 50 meters by 50 meters. So it is the minimum size of the field. If the field is bigger than that, we can use more points. We can measure more points in one field. So we had 2 big field campaigns in our JECAM sites in Manitoba, in Canada. One was the SMAPEX 2012. The other one was last year, SMAPEX 2016. During these 2 field campaigns, we collected a very good data set. It's a very complete data set for agriculture application. Actually, one of the main objectives of these 2 field campaigns was to collect validation data for developing and testing the algorithm for SMAP soil moisture products. But we also have very good data sets for agriculture application like LAI and biomass estimation. The SMAPEX 2016 was for 6 weeks of ground measurement, and 2016 was 4 weeks. And we measured different parameters like LAI, biomass, soil moisture, technology, soil roughness, and other parameters, crop parameters as well. These 2 data sets are, I think, free, and if anybody needs to access these data sets, we can send him the link to access the data. So I'm going to talk about a little bit about the strategy that we use to collect our ground measurements. For the soil moisture, we collected 6 sites in each field. We used 16 sites. We used 3 of these 16 sites for vegetation sampling. As you see in the yellow boxes, site 2, site 11, and site 14, these are the sites that we use for vegetation sampling. Because we had a lot of ground sampling, we used site number 2 for the calibration, and site number 11 and 14 for the validation. In each site, we measured soil moisture using the Steven hydroprobe. We measured at 3 points, at the top of the reach, at the middle, and at the bottom of the reach, and at each of these points we had 3 replicates. So what actually we did is we measured the top soil moisture, top 6 centimeters soil surface, and for sure it is important to have the soil moisture measurement coincidence with the flight overpasses, what we had during these 2 field campaigns. Very important point is to have calibrated soil moisture data. So in each day of sampling, In each field, we had a core soil sample by using. So you see that we had a core sample in one site in every field. We put it in the tin and then in the plastic bag, and then we measured the wet weight and then put it in the oven, dry the sample, and then again waited for the dry sample. So these are actually values used for calibration of the Hydra probes measurements. For the biomass sampling, our method was based on the destructive sampling. So again, for site 2, 11, and 14, we sampled the biomass. For wheat, canola, and pasture, we use a half-meter by half-meter square, and we put it on the canopy, and then we collected all the vegetation above the surface. For beans and corn, we collected 5 plants in 2 rows, so totally 10 plants. And again, we waited the wet sample and then put it in the dry room for a couple of days to dry the samples, and again, we waited the dry sample. And for LAI sampling, our measurement was based on the hemispherical digital photos. So in each site 2, 11, and 14, in each site we collected 14 images. So 14 photos, 7 in each row, it was in 2 rows. So by post-processing of these 14 photos, we estimated the LAI value. So one important point during the LAI sampling is that to keep the camera, to the hemispherical camera, the fisheye camera, it's important to keep it 50 centimeters above the canopy. And if it's not possible at the end of the growing season, for example, for corn, we should keep it at least 50 centimeters below the canopy. So this distance is the minimum amount, so it's important to consider this value during the sampling. So is that a point, Heather, for the sampling?
Yeah, I guess the reason that we wanted to show you that is to sort of show you the methods that we took during SNAPVEX for both the soil moisture and the vegetation sampling. That's not to say that there aren't other ways to collect the data, but you know, the point being that we have to have, you know, well-calibrated moisture and biomass LAI. And we did have a lot of debate about how to collect LAI. We have had that debate for a number of years, but for SNAPVEX, we settled on the hemispherical photos to take those measurements. You know, and you know, in terms of the number of data points, we've, as all of us probably have debated a lot about what's the minimum data set required, how many points do we need, and I guess the short answer to that is as many as you can collect. And certainly in SNAPVEX, that's what we did. You know, we collected data over 50 fields. So we had a lot of people out in the fields collecting data, obviously, but, you know, we collect as many as we can. And part of the advantage of this type of activity is the intent is if the in-situ data is well calibrated and comparable, we'll be able to pool data together. So if you don't have enough data over your site, if it's brought together with data from other sites of comparable type and quality, then we can generate this larger data set. So, you know, some of the partners have asked us about, you know, they don't have a huge number of data points, and we've been telling them that that's just fine. Send us the data, and we will draw it in and put it together with the other data sets. So anyway, I guess the point is that, you know, we just wanted to show how we collected data as, you know, from the SNAPVEX campaign to give you an idea of what we're looking for. Are there any questions on the data collection part of it?
Yeah, that, you know, each site has its JECAM site has some differences in data collection.
Yeah. So that's why, you know, right now Laura is bringing in all of the in-situ data. We're taking a look at it, and Mehdi's looking at the LAI biomass part. Biomass is a little easier because it's pretty much a standard way to collect it. LAI is a little different. So we are looking at all of the partners in situ data to see how the data was collected, how comparable it is, and whether it can be pooled in with the rest of the data or whether it would have to be sort of a standalone data set. So we're just in that process right now, and that's why there'll be a lot of back and forth with you, questions about your data and that type of thing. Okay, so we're going to talk now about the modeling side of things.
Yeah, so the model that we are using for the LAI and biomass estimation is a semi-empirical water cloud model. As you see here in the water cloud model, it has 6 coefficients that we usually estimate these coefficients for every crop type. We have already tested this model for corn, soybean, and wheat, and very good results were obtained. So we calibrate this model, as I said, for every crop type, for every polarization, and for different technology stages. So here are some results from our past experiments. So these are the results that were obtained from C-band RadarSat-2 and L-band UAV SAR. So the top left graph is the result, the RMS error value for LAI estimation from RadarSat-2. During the growing season, you see that the RMS error value will increase from the early season to the end of growing season. So, for instance, for the early growing season, we can estimate LAI. So these are the accuracies on the validation points. So roughly, we can estimate it by RMS error value of around 0.5. And going to the end of growing season, the RMS value will increase to around 1. So for soybean, the next graph showing the result for soybeans, the RMS value decreased because of LAI for soybean is lower than range of LAI for corn. So the 2 bottom graph are the results that obtained from UAV SAR, which is an L-band. So for corn, again, they show the similar pattern during the growing season. The results for corn are very close to what obtained from RadarSat-2, but for soybeans, very different. And we can say C-band with a lower wavelength gives us better results for lower like soybeans. So we see a table here that's showing the statistics. So for corn, RMS error value 84 using from polarization with R-square of 0. And for soybean, it was RMS error value of 0.64 to R value of 0.8. So here is a map showing the LAI map derived from the RadarSat-2 for 2 crop types, corn and soybeans. The left part of the area is covered by corn, the right part is soybean, and it shows the variation of LAI during the season from June to end of August. This is another example. It shows a subset of RadarSat-2 image. It's map and the LAI map. So we use here actually the coefficients for soybean and but still by using corn coefficients for wheat crop types, still we can see that we can distinguish between these 2 crop types. So after using applying the coefficient deriving the LAI map, you see how we can distinguish between soybean, corn, and wheat crop types. So we also calibrated the model for the biomass as well. Here is a full scene of RadarSat-2 and the derived biomass for June 27th for wheat crop type, and also the derived soil moisture map for wheat as well. And also we did the same thing based on the L-band UAV SAR, the biomass map, and the soil moisture map. So as I explained, the model also gives us the soil moisture map as well. although we focus on more on LAI and biomass part, but it also gives us a soil moisture. So here are the soil moisture map for 3 locations over the area. These are for wheat fields. So you can see the variation of soil moisture from June 12th, June 27th, and July 14th for 3 different locations. That shows the, the decreasing of soil moisture during these 3 days. So we also calibrated the model for the heads of wheat, which is actually showing the wheat yield. So, and this is an example of derived biomass for heads of wheat. Again, from the early growing season to the end of growing season, it shows how the biomass of heads of wheat increase. So I'm going to talk a little bit about the toolbox that we have. So here is a toolbox. It can be used for any radar data. It can be used for both C-band and L-band. It can be radar Sat2, Sentinel-1, or any L-band data. And also we can use this toolbox for optical data as well to produce LAI, biomass, and soil moisture maps. So what we need to use this toolbox is just radar data or the optical data if you are working based on optical images. So the radar data, as I said, should be at least with 2 polarization, HHHV or VVNHV. The incidence angle can be derived from the radar images itself. We usually use PCI Geomatica to derive the incidence angle layer and put it in the toolbox. So it just needs the radar data. As long as we have good coefficients, the only input to the toolbox is the radar data or the optical data. So it's better also to input into the toolbox a crop map because we have different set of coefficients for for different crop types. So by using the crop map, for sure we can get better results. But still, if you don't have crop map, we can use this toolbox by using the coefficient of just one crop, like coefficients of corn for all the crop types. So the tools also can be used for optical images as well. It produces a LAI and biomass map based on the vegetation indices. It works based on NDVI, simple ratio, RTVI, and red edge simple ratio, and then gives us the LAI and biomass map. So as you see in this graph, by combining the optical and SAR data, we can have a much better temporal trend of LAI or biomass map during the growing season than using just optical data. So the SAR data can very good fill the gap that we have from optical data. And here we recently did a comparison between LAI derived from radar Sat2, and LAI derived from the rapid eye. So this graph, the graph on the top left shows the results for LAI estimation from radar Sat2, and the right one shows the results from rapid eye. So you see they are very close of the accuracy, for instance, for RMS error. So the values from rapid eye is 0.53 and radar Sat2 is 0.54. The R values are close to. So after that, we cross-calibrated these 2 LAI estimations, the LAI estimated from radar and optical, and the actually red signs here are actually, red symbols are the non-calibrated points, and the cross signs are the cross-calibrated ones, and you see they are very close. So even after cross-calibrated between radar and optical, we can see they didn't change a lot. So we can say the radar and optical are very close in terms of the LAI estimation. So Laura will give you some updates on the project.
Yeah, I just wanted to add a couple of comments while Mehdi was talking there. So, you know, the results that you just saw, of course, these are, you know, some of our initial results, but I wanted to emphasize that the results the modeling and results that Mehdi presented, he actually went into some archive data from the U.S. So he went into the SMEX campaign data and pulled that historical data in and pooled it with the data from our 2012 experiment, and we will be pulling in the 2016 data shortly. So so we've already taken data from other sites and pooled it into the modeling, and that has really helped a lot in terms of improving the amount of data we have, and obviously the calibration and the inversion of the model. So it's already an example of pulling the data together to come up with a more robust result. Having said that, you do see we do have some data gaps in terms of the range of biomass and LAI that we have. We need to build the model, make it make it stronger and more robust, and so that really is the focus of at least the Canadian aspect. I also wanted to say that, as Mehdi was suggesting, this approach, because he's using dual polarizations, there's no requirement to feed the model anything other than the radar data. Having said that, there are other methods. So I know, I believe in Belgium, for example, that they are also using the water cloud model, but with a slightly different approach where soil moisture data is provided into the model. So I think we're quite interested in assessing that approach as well. So there will be other approaches that we're interested in as well. So I just wanted to make a point.
Great. Thank you, Heather.
All right. So hi, everyone. It's Laura. And just to ask if anyone had any other questions for Mehdi about his methods or anything. Okay, well, I have just a brief update because Heather gave a great sort of overall idea of what's going on with the project, but this slide kind of gives you an idea of who is actually involved with this, and this is our circle of the JECAM partners, and the blue ones, well, it's over 20 sites, and to sort of highlight, the yellow is an indication of who has actually uploaded their in-situ field data, and that data has been received, and we are looking at it and quality control and figuring out how to use it in relation to what Mehdi is doing and then what we are doing with the crop inventory modeling inventory methods. As well, as Heather said, we do have a student who has been plowing through the enormous amounts of EO data that is out there and available for all of these sites, and so she has been working very, very hard and downloading and has started the pre-processing on several of the sites. And I believe she said to me that she's almost completed on 2 of the sites, and we should hopefully be creating the stacks with the validated and quality controlled in field data for 2 of them shortly. So we're hoping that once we get those stacks created, then we are going to run our classification method and see how this works. This is sort of, we're at the very beginning, so we have to work out the problems, but we're getting there. So over 20 sites interested in the experiment overall, and then for Mehdi and Heather's portion with the LAI and biomass, we have a big group of about 11 sites who have expressed interest in whether or not they have the data now or going and they're interested in collecting the data in the next years. It's great because that gives us a big pool of data to add to Mehdi's model and to other people's model. So we can go to the next slide. So as we said, the downloading of the satellite data is ongoing, and as for the RADARSAT-2, like Heather said, we will be meeting in the next week or so and discussing going forward for next year's collections, and we are, looking to see what we can do about that. The FTP has been provided to the participants who have sent in their participation form. So if you've sent in that form that said, I want to do component 1, all of it, and component 2, all of it, or whatever you chose, we have sent you an FTP username and password, and that is for you to use to upload your data, in situ field data, to us. If you've uploaded your in situ data and you have not heard back from either Medi or I, can you email us? Because that means we probably have not seen it or something has gone wrong. But we have emailed back everyone who has sent in their field data and at least confirmed that we have received it and we are working on it. Medi is also looking at some other non-JECAM potential data, and that's like MicroWEX, AgriSAR, CanX, SMEX, and SMEX02 and SMEX05. So we are looking at other potential data sources, and if you know of other potential data sources, not only for this first component, but we have to look forward to our components, the 3 and 4, which are multi-frequency. So we will be looking for other frequency SAR data, X-band, L-band, some things like that, as well as for the future. So if you have other data sources that are available either over your sites or other JECAM sites, we want to know about it. So please let us know.
And I guess, sorry, Laura, to interrupt, that's one thing that I wanted to say as well. At least for the Canadian sites, for 2012, 2016, and even this year, 2017, we have both RadarSat 2 and TerraSAR X data over our site. So there is also X-band data. We do, part of Medi's plan is to look at a multi-frequency retrieval, and I think the multi-frequency classification is on Laura's list as well. But for others who are interested in more than one frequency, we do have X-band. L-band has always been a bit difficult to get. We do have a little bit of L-band data, but certainly some good contributions from TerraSAR X.
Okay. And the other thing that we kind of want to point out that we really want to keep in contact with you and let you know what's going on and keep you up to date with the project. So we do have the site on the JECAM SAR website, and so you can see on the right there that that's where our site is, and you can see we have the project plans on there, the participation form, some articles, and we will be putting up this webinar. We're recording it right now, so that will be going up. So if you've missed some things or you want to go back and review some of the items in this webinar, you can go on the website. We'll get it up there as soon as we can. And as well, we're doing this monthly newsletter. And so this is just a little bit of a reminder and an update to you every month of what's going on with the experiment and where we are. And if you've missed an email or you've missed a webinar, or you hopefully will get the newsletter and be able to take a quick look and see if you're missing something or if you want to talk about something. Medi and I are always available to speak with you, and we can, as Heather said, we're arranging weekly phone calls with partners. Of course, in our summertime, and a lot of you around the world, we're often off either in the field or on holidays, so we'll probably be gearing that up more as we move on in the year, but right now we're starting to talk to people on a weekly basis. So that's basically where we are right now. And if anybody has any suggestions about our communication or you know, have any sort of suggestions, again, about what Heather said of the data policy and the authorship, co-authorship plan, we are very excited to see and get your responses from that. So that's about it for my update. And if Heather and Medi have anything else to say, we can open it up to questions and comments.
Hello?
Oh.
Hello?
Is that Diego? Yes, go ahead.
Yeah, yes. I lose the connection last 5 minutes, but I'd like to know if you talk about or you're going to talk about a minimum number of samples, minimum number of fields, or we need to agree between the partners in a minimum number to make the field measurements, number of fields. Or I think the sample per field is defined in the experiment MapBec, but the number of fields is something that needs to be defined.
So I'll say something about the LAI biomass, and then I'll let Laura talk about the classification because it is a little bit different. So as I was saying, we don't have per se a minimum number of data points even on the classification side. You know, Mehdi talked about this 20 to 30. It's, you know, obviously the more data points we have, the stronger the model will be. You know, something less than 10 is probably not going to be too useful. But having said that, if the data, as I said, if on the LAI biomass side of things, if your LAI and biomass are being collected over the same crop types or you know, similar crop types to what we're using, and the data is being collected in a similar calibrated way, what we're hoping is to be able to bring your data set in with ours. So as I was saying, Mehdi has already done that. He went to some of the SMEX data that was collected 10 years ago in the U.S., and he brought that data in, the LAI biomass data in, as well as the, I guess it was L-band data in to our data set and pooled it with our data set, and that worked very well. But of course, the data has to be comparable, and it has to be appropriate to pool. So I guess what I'm saying is that, you know, we can talk with you offline about the specifics around the data collection, but our hope is to bring all of the data together, as much of it together in a pool as we can. And it's for that very reason, you know, our SMATVEX campaign, in 2012, we had 75 people working on that campaign in the field, 75. And even with 75 people working on it, we felt we didn't have enough data. So what that tells us is that, you know, nobody can do it on their own, so we do need to bring the data sets together. So that's kind of our approach on the LAI biomass, and we can talk with you offline if you have more specific questions. The classification is a little bit different, so I'll let Laura talk about that.
Yes, as Heather said, of course, a lot of our method particularly, and a lot of methods obviously use training and validation in their classification, and so obviously it becomes difficult if you only have one field of a certain crop, as you don't have anything to validate it with if you're using it for training. That being said, we're looking at the data coming in, and you know, maybe there are within the area of sampling, particularly the JECAM sites, there might be particularly rare crop classes. We're looking at potentially minimizing those and just looking at very sort of major crops, similar to what Mehdi and Heather are doing, wheat, soybeans, others, so that we have, you know, an appropriate or significant number of fields that we can use and split into a training set and a validation set. So what we hope, because I'm going through and QCing all the field data, is that we all use the same training and validation for each site, so that we can eventually at the end statistically compare the results that we get. And then put out the basic field data sets, and if people have other methods that they use that they don't require, you know, that many training and validation points, then they can use the original data sets. But we want a standardized training and validation set per site so that people are all being consistent in that way.
And yeah, Elizabeth, just before you ask your question, it just brought to mind, we did publish a paper not long ago around you know, sort of this question about the number of training and testing data sets that you need to provide an accurate crop classification. And we can share that publication. We could actually upload it on the site. And it's not an easy question because, like anything, it depends on the variability in that class. So, for example, in corn, we tended to find that, you know, we needed fewer training and testing data sets because there was low variability in the signature for that crop. So some crops you can get away with fewer samples because the variance in the signatures are low, and for other crops you need more. So we'll upload that paper actually because it's quite interesting to look at how the accuracy changes as you reduce the number of training samples on a class basis. So that might help answer your question as well.
I have two questions. First one is related to this training and validation. Some of the crops, if they are classified year after year, effectively the requirement for training might be reduced. No, is it not something you observed?
Yes.
Okay. The second question is more for the management of the JECAM project. Maybe we could give us some ideas of which sites should be grouped together to make a better site, like the regional needs for data provision, and then we can try to accommodate the needs this way too.
Yeah, and that's a good point, Elizabeth. So, so in Mehdi's case, looking at the data from SMEX, which was collected in the U.S. Midwest, it was, you know, it's a very similar type of cropping system as their own. It made sense to pool those together. So that is something we'll look at to see, you know, whether we have sort of these subsets of pooled data, because it makes sense because the cropping systems and the varieties grown in that area are, you know, are similar and can be grouped together. And I agree with you. I suspect there won't be one, you know, one data set that all the data goes into, that we will have sort of these regional data sets. Until Laura and Mehdi have a chance to take a look at the data as it's coming in, we won't know whether we have one data set or, you know, regional data sets, and how many of those regional data sets we have.
I have a question. This is Sergey, UMD. So my question relates to the uncertainties and quality control. So when you provide the coefficients, for example, of the calibrated model, will you provide also uncertainties that have been estimated through the calibration? And again, with the toolbox, when you estimate the retrievals, will you be able to provide in quantitative or qualitative measure, like per pixel, any uncertainty, or whether the retrieval was confident or not confident? Because I'm asking because if, for example, then to use LAI for crop yield prediction or intercomparison with optical data, it would be nice at least to know, at least in qualitative fashion, the confidence of how good retrievals are.
Yeah, that's an excellent point. And you know, part of the reason that you know, I can speak for myself, I was quite interested in this JECAM initiative, is that I'm always quite nervous about releasing you know, models or methods that first of all aren't well validated over space and time. And we always have to, with these methods, we always have to be able to provide, you know, some sort of, like you said, uncertainty or error statistics around it. And that will definitely be part of that plan. You know, even our annual inventory for Canada here that's based on satellite data, you know, there's metadata that goes with that product that says specifically on a crop basis what the uncertainty is from the classification. We would do a great disservice to the downstream users if we didn't provide that type of data. So, you know, Mehdi provided some, you know, sort of error statistics. This would be a great contribution from others on the team, actually, if you have some specific ideas around how the uncertainty could be estimated and presented. We'd be really interested to hear that. Because as you said, we don't want models and methods being released to people who are doing yield modeling where the model uncertainty is, or the errors are high and the uncertainty is unknown.
Yeah. Okay, thank you. Yeah.
Do we have other questions or comments?
I have one more question.
Okay. Sure.
Is there a deadline for us to provide the in situ data?
That is an excellent question, Thorsten. Thank you for asking it. We realize that a lot of people, you know, like I said, may be away or in the field. So we were, yesterday in our update meeting, we were actually talking about this. And Well, we don't want to disclude anybody. What we think is that for sort of a first go-around, we want to get moving on it. We want to get the stacks back out to the partners. So we are looking at potentially making a deadline mid-October for upload of the in-situ data. And that seems like a while, but again, a lot of people are away and not in the office, and so we want to give them an opportunity when they get back to upload. But if you have it and you're ready to go, you know, please upload it, because as soon as it's uploaded, we can start working on it and start the downloads of the data. I'm not downloading data over sites where I don't know where the actual field data is. So it's a trigger to start the actual EO processing to get the in-situ data uploaded.
And one follow-up question to that. Are you also interested in 2014 data?
For the LEI biomass, we're interested in anything. So as you can see, we'll take anything. As you can see, you know, METI's going back to 2002. So obviously we don't have Sentinel-1 and RadarSat data, but there are airborne data available for those. So, you know, for the class, well, even for the modeling part that we're doing, I mean, we have to have in-situ data and some sort of Earth observation data, satellite or airborne, to accompany it. But if those two are met, then absolutely.
Well, similarly for the crop classification, as long as there is a radar component, we can look at it, and that's the thing. We have to have some radar imagery at that time, so that would be the limiting factor for when the field data has been gathered.
So I just wanted to follow on with what Laura said about the deadline. So we do have to set a deadline, otherwise it will be a never-ending process for us, and we do want to get on with some of the analysis. So, you know, we do hope that the partners can meet that October deadline. Having said that, if for some reason, because you're planning new data collections or, you know, other reasons, you can't meet that deadline, you won't get left behind. You know, we will proceed with sort of the phase A data that we've collected by October, and then, you know, at some point we can bring in new data as it comes in after October. So don't be disheartened if, you know, if you can't meet that deadline. It just means that, you know, your data will be brought in at a later time.
And further to that, we also have to initiate the next two or 3 activities of the experiment overall going into 2018 and 19. So looking at multi-frequency and looking at some of the other experiments we wanted to try. So we would be back talking to you about future collection and field data collection for next year in any case. So it could be an easy add at that point.
Because
Thank you very much.
There has to be done the plan if you could order RadarSat for our test sites.
Yeah, we're going to, as we said, Andy Davidson, who has been, you know, sort of the lead on the new data acquisitions, his team at least, he's on holidays this week, so he's back next week. So we plan to sit down with Andy hopefully next week to discuss new data acquisitions over the sites. My understanding, and please don't hold me to this, but my understanding is that some of the sites there's already a plan in place to collect data next year over some of the sites. So there was going to be a repeat of data collection in 2018. But I think what we're talking about here is a new site that is not currently on the plan, and that's what we're going to discuss next week. We are certainly going to make a strong case that there will be new data acquisitions, but we would only advocate and push for those new acquisitions if only under the circumstances where there is, you know, there's good ground data that's going to be collected. So if you are planning to collect, you know, good ground data that's going to support either the crop classification or the LAI biomass sampling, you should send that information maybe to Laura so that we can we can advocate on your behalf.
Okay. We in Poland, for instance, where we do measurements, there are also root vegetation, root crops. From this, what you have here, we don't have rice and we don't have soybeans. Our wheat and other cereals, you know, some and maize, for instance, as well. So something like that, yes. That, or are you interested in all collection of vegetation? So root vegetation, like beetroot and what else? They are mostly beetroot.
Yeah, so, you know, as Mehdi said, we were sort of focusing on, you know, sort of the global crops that, you know, that have high importance globally. Having said that, there's nothing to stop us from modeling other crops. Well, nothing to stop us other than a good data collection. So for other crops that partners are interested in, they can also be modeled as long as, I mean, the methodology can be tried on any crop type, but we need good ground data, in situ data to parameterize and calibrate the model. So if you're collecting that data, then there's no reason that it can't be used in the modeling. We're also interested in canola because it's such an important crop for Canada. It's a bit trickier with radar, I think, on the modeling side. But that will be one that I think Mehdi will be looking at, is canola. But if you have good ground data, the method can be at least tried for any crop type. And like in terms of, you know, other small grains outside of, I mean, we've been parameterizing it for wheat, for spring wheat, but, you know, we haven't looked at other small grains, but that could be assessed as well. Are there other questions?
Yes. Can I? That's a question from the Space Research Institute of Ukraine. You mentioned that you perform some pre-processing for satellite data. Do you plan to share some description of this process?
All of the methodologies will be fully transparent, open, shareable to the partners. So I'm not sure, Laura, if you have a document yet about how they're being processed.
Well, we do. We have the papers that we're basically following our typical crop inventory pre-processing methods that we use on our operational crop inventory. So we do this on an annual basis, and we ingest the Landsat and, in our case, RadarSat 2, but we're altering this to include Sentinel-1 and Sentinel-2. So we have a fairly standardized method of pre-processing the data, and what I will do is when I put out the stacks for everyone to use, you'll have a very described method of what we have done to that data, and in terms of ortho and filtering of the radar data and any of the other types of calibration that we have done. So that will be very clear coming out. The one thing that we've been thinking about is, because we want this to remain consistent across sites, we want to make sure that everybody, when they're trying their own methods, particularly for the crop inventory, they're using that same data set. That being said, we're trying to decide if we would send out also raw data, because if you want to try your own pre-processing methods, that's great. And you can do that and run your pre-processing methods, but we'd like to be able to compare at the end the results, to have a standardized pre-processing take place.
Yeah, and I think it's fine if you know, I totally agree with Laura that, you know, for our purposes, from the Canadian perspective anyway, and I think the Canadian Space Agency, we have to have this intercomparison. So data has to be handled in the same way. But as Laura said, having said that, there are other approaches to the pre-processing, and if other partners are interested in, for example, looking at the effective filtering on, the classification, as a sort of a separate research question, there's no problem whatsoever with that. And, you could have access to the raw data, the sort of unpreprocessed data, if you wish to look at, some of those other issues. As I said, with the SMAPVEX activity, it's been pretty incredible, the research spin-off that we've seen from it that have really nothing to do with SMAP itself. So, so we do encourage to use the data to answer, any research questions, but there will be this standard comparison for the purpose of reporting on this project.
Thank you.
Is there any other questions?
So please, so I think we'll draw the webinar to a close, and thanks to Laura and Mehdi for all of their hard work. As I said, they're working full-time on this for the next, almost the next 3 years, so that's a great resource to have. Please contact any of us at any time if you have any questions or concerns or comments. It is we do want it to be an iterative and a partnership so that it's not sort of a one-way exchange. And please feel free to contact them at any time. So I think with that, we'll close the webinar, and as Laura said, this was recorded this time, so we will upload that to the JECAM site, so you can go back and test whether we actually answered your question or not.
Okay, thank you very much.
Thank you very much.
All right, thank you.
Thank you.
Thank you.